segment proofs. Okay, so tell me about the proofs we have been doing thus far. You're supposed to set your timer, bro. It's fine. It's fine. Everything's fine. Tell me about your proofs that you've done so far. What kind of proofs have they been? Algebraic, meaning you are doing things like addition, subtraction, multiplication, division, and then we just brought in transitive, substitution, those types of things, okay? Today, we're going to take all those things that we've been working with, but now kind of pivot a little bit to make them feel more geometry. So you're going to have segments. Eventually, you're going to have angles. We're not going to do that yet today, but we're going to do that soon. Hopefully tomorrow. We'll see how today plays out. So there's going to be a lot of segment stuff that comes into play, okay? You can see up at the top, these are all the properties of equality that we've been working with. You'll still have the option to use those. It's just not going to be all those anymore. So when we use those properties, those are like, this is equal to that, right? They're all used with equal signs. The properties of congruence, we'll use a congruence symbol. This guy, okay? So here's where there's this extra step that often comes into play because we have to transition from equality into congruence. It kind of feels like this unneeded step at times, but it's how we say, okay, if these are equal, then we also know they're congruent, okay? So we're moving into congruence, that type of thing. So let's just talk about the properties of congruence. Just know moving forward, if you don't write of congruence or of equality behind it, I'm not picky about that. But I want you to understand there is a difference. So it says for any segment AB, the reflexive property, tell me about the reflexive property of equality. What did it say? Brooke equals Brooke, right? A equals A. They're identical. It's like looking in a mirror, okay? So for a segment, it's this. AB as a segment will be congruent to AB as a segment. Okay, that's the reflexive property when we're working with segments instead of just a letter. The symmetric property says if AB is congruent to CD, then what? Symmetric property. CD will be congruent to AB. So remember, symmetric property just swapped the order that we were doing it in. Okay? And then the transitive property would say if AB is congruent to CD and CD is congruent to EF, then what? Is congruent to, but yes, AB is congruent to EF, right? We take out the two in the middle that are the same, and what we're left with is this new congruent statement, okay? So those are the properties of congruence that are going to come into play. The definition of congruence, okay, it says segments are congruent if and only if they have the same measure. So basically what they're saying is if AB is congruent to CD, then it means the length of AB, notice there's no bar over that, is equal to the length of CD. Okay, so congruence has the segments. Equality doesn't have the bars anymore, and it just says they are equal in length. Okay, same thing can be flipped around. If AB, is equal to CD, so if the length of AB is equal to the length of CD, then segment AB will be congruent to segment CD. Okay, so if we're talking about congruence, there's a bar over top. We're talking about the segment. If we're talking about equality, there's no bar because we're saying length equals length. Okay? But they're essentially saying the same thing. They're very similar. Questions on that? Okay, tell me what a midpoint is. A middle point, right? It's a point in the middle of something. Cassie. Samir, you are killing me today. He's trying to take notes and be studious, and you're stealing his notes in the middle of it. It was your fault you left. You went to the bathroom. He didn't go to the bathroom. Get them later. You're killing me. Okay. I'm totally recording this too. That's going to be on video. It's great. Definition of a midpoint is just a point that is in the middle. Okay. So if you have a midpoint, it says M is the midpoint of segment AB. Can you tell me how we mark that? How do I mark it on this segment that is a midpoint? 2 little hash marks, yeah. So AM is congruent to MB, okay? That's what we're looking for here. AM then is equal in length to MB, okay? That's a midpoint. Now, the segment addition postulate, we did this already. This is just a reminder, okay? It says if A, B, and C are collinear, then AB plus BC will equal what? AC. Okay, so segment addition postulate, definition of a midpoint, those things aren't new. We talked about this already. It's just we're doing a quick refresher because you're going to use those today. Scarlett.
What does collinear mean again?
On the same line.
Okay.
So if those 3 points are on the same line, that will be the situation. Okay, so we're just going to practice using the different postulates, theorems, properties, all of it together before we throw it into an actual proof, okay? So there are 14 blanks here with 14 different properties, theorems. I mean, they're not all different. Some of them are going to get used more than once, but a bunch of things. Actually, maybe not. Maybe not. I think they're all used only once. Yeah, so let's walk through it, okay? It says if PQ equals PQ, then segment PQ is congruent to segment PQ. Do you know what that is? That is the definition of congruence. If they are equal in length, then they are congruent segments, okay? That's the definition of congruence. This one says if K is between J and L, then JK plus KL will equal JL. What's that one? Not definition of a midpoint, because it doesn't say that K is in the middle. It just says it's between them. What is that? The 2 parts added together equal the whole? That's segment addition postulate. Okay. What's number 3? EF is congruent to EF. It's the reflexive property. And again, they're going to say it's the reflexive property of congruence. I am not picky about that. You can just say the reflexive property. Number 4, if RS equals ST, then RS plus XY equals, TU. I don't know where I got ST. If RS equals TU, then RS plus XY equals TU plus XY. What happened to that first one to make it the second one? It's the addition property. Yeah, we just added XY onto both of them. What's number 5? If AB equals DE, then DE equals AB. That's the symmetric property. It's the symmetric property of equality, right? Not congruence, because there's no congruent symbol there. But again, I'm not picky on that part of it.
So if future down the road on a test, if we're not specific about it, does it matter?
If you just say symmetric property, I will take it. Okay. You don't need to say of equality or of congruence. Yeah. Okay, number 6. If y is the midpoint of xz, then xy equals yz. What's that? Definition of a midpoint. If FG is congruent to HI and HI is congruent to JK, then FG is congruent to JK. Take out the 2 in the middle that are the same, and you get the transitive property. Okay. Okay, I'm going to let you finish those next 7 on your own or with someone near you. See if you can get them. Tell me what you got on number 8. Subtraction. Yeah, look what happens. you have, if we take away a CD here and take away a CD there, this is what we end up with. So that's the subtraction property on number 8. What'd you get for number 9? If PQ plus RS equals TV and RS equals WS. Yep, so they substituted right here. So substitution. What'd you get for 10? That's the definition of a midpoint. Yep. $11. Here's your clue on this. If one has congruence and one has equality, but everything about them is the same, that's the definition of congruence every time. So it can go from equality to congruence, or it can go from congruence to equality. We say definition of congruence. Okay. What'd you get for 12? So it was this. All of a sudden now CD is by itself. Not reflexive. Subtraction. We took away the DE from both sides, right? Minus DE. So that's subtraction. Okay. How about 13? What'd you do? Multiplication. It's tricky because some people are tempted to say division here, but you didn't divide by 2. You multiplied by a half. So I get where you say division, but because they wrote it as a 1/2 out in front, that's multiplication. So just be careful with that. I would say this is multiplication. I would probably give you partial credit if you told me division, but it is ever so slightly different. And then 14, what'd you get? That's transitive. Okay, the 2 in the middle are the same. Get rid of them, and you're left with that. So far, so good? Ready to try some proofs? Let's do it. All right. We're going to start on number 1. Now, here's where segment proofs are a little bit different. There's usually a picture to go with it. And that picture makes all the difference in the world. You want to use the picture, you want to mark up the picture, you want to, like, as you go, note what you know as you know it, okay? So this one says, given that E is the midpoint of DF, prove to me that 2DE equals DF. And this has the steps for you. So it's just a matter of how did I get there. So what is step 1? It's your given. E is the midpoint of DF. Okay, now to get from that, the statement that it's a midpoint, to the fact that DE equals EF, that these two are equal in length, why do we know they're equal in length? It's the definition of a midpoint, right? They told us it was a midpoint. So the definition of a midpoint tells us that they will be equal. Okay, definition of a midpoint. All right, so we were here. DE equals EF. Now they say DE plus DE equals DE plus EF. What did they do?
Substitution.
No.
But you substitute, like,
We didn't substitute. I know why you think that. But we actually did not substitute because the statement was this. So if we were going to substitute, we could say DE equals DE or DE equals or EF equals EF. That would be substitution. What did we do to what it was? It was DE. Now it's DE plus DE. It was EF. Now it's DE plus EF. Addition. We added, right? We added that DE to both sides. So that's the addition property. Because we added the same thing to both sides. Okay, now we're here. This didn't change. The right side stayed the same. What happened on the left side? simplify, right? We just combined like terms on that left side. So you can just say simplify for that one. Now what? I don't like how they did this. Oh, I see. How do we know that DE plus EF equals DF? How do I know that this plus this equals that? It's not a definition, it's a postulate. It's the segment addition postulate. The part plus the part equals the whole thing. So that's segment addition postulate. Hey, you're going to want to pay attention to this. This is where it gets hard. Hang out with me. Okay. Now the last step, 2DE equals DF. Do you see it? Look at this step. Look at this step. Tell me how I got to that step. I would take substitution. What do I like better? The transitive property. The two in the middle that are the same get taken out, and what we're left with is the transitive property. Okay, but you could say I just substituted DF in place of DE plus EF. Questions on that? We're getting a little fancier, right? A little bit fancier. Okay, go down to number 3, which is the next one for you. Given two things, okay? PQ congruent to TQ and UQ congruent to QS. Prove, okay, so think about what that's saying right now. Given that PQ is congruent to TQ, and given that UQ is congruent to QS, okay, notice those markings. That's a big deal. You got to make sure you mark them appropriately. Prove to me that PS, so this whole piece, is congruent to this whole piece. Okay, the whole thing is congruent to the whole thing. What is your first step? It's your given. Okay, and I highly recommend you mark it because I think it helps you see what's coming. The next thing they say is PQ equals TQ and UQ equals QS. Why are they saying that? Definition of congruent. If they are congruent, they are equal. Okay, so that's definition of congruence. Okay, now look at step 3. It says PQ plus QS equals PS. Think about what that's saying. PQ plus QS, so the two parts, equal the whole thing. What is that? That is the segment addition postulate. And if you look here, they said the same thing there. TQ plus QU equals TU, the whole thing, okay? So both of those are the segment addition postulate, okay? All right, so then look at step 4. It says TQ plus QS equals PS. Look directly above that. Is that the same thing? No, but it's very close to the same thing. Girls, you are going to struggle so much if you don't pay attention to this.
I was listening.
Lock in.
Hey, that's not it.
What happened? Why? Up here it said this. So we're going to substitute in place of the PQ, the TQ, right? That's substitution. right? Because we knew that PQ equals TQ. You don't have to write that in, but I'm just showing you where it came from. What's step 5? Kind of looks like this, right? TQ plus QS equals TQ, or TU. TQ plus QU equals TU. What happened? It's substitution again from this guy. So this is another substitution, right? Because we used QU is equal to QS and substituted that in. Do you see the next thing? It's not subtraction. Let me show you.
Is it transitive?
Yeah, how'd you get that?
Well, it looks like simplifying, but it's not. Or, I mean, it looks like substitution, but it's not.
Right. What happened was if we had TQ plus QS, that was here, right? And we had, I just lost my other one. PQ plus QS equals PS. TQ plus QU equals TU. So we substituted and we substituted, and now we took out the two in the middle that are the same. Oh, that's why I'm not far enough down. So PS equal to TU. If we take out these two things that are the same, we're left with this statement right here, right? That's the transitive property. Do you see it? These are getting trickier, huh? What's your last step? Definition of congruence. It went from equality to now the exact same thing being congruent. That's definition of congruence. Questions on that? Okay. We're going to stop there for right now.